Okay, so simplifying roots, we are looking at doing some old school stuff that you've done before, like square root. Remember that? Great. Okay, so what we're looking at, we'll just start with something easy, like 25. I'm going to run it through my example, my explanation. I like it a lot. So what gives us 25? Well, that's 5 times 5. All right. So then what we're doing is we're going to cover up my mistake. There we go. Okay. So the radical here is the gel. All right. So since it's a square, that means I need 2 values. So if I circle those 2 values, these 2 prisoners dig a tunnel out, but only one makes it out. So the square root of 25 is equal to 5. So 2 are digging the tunnel, 1 gets buried, and only 1 makes it out alive. That's why I do it. Okay, so then we can also have stuff like this where we have the nth root, correct? All right, nth root can be any number. All right, and it's usually going to be between 2 to n. All right, so usually we don't write 2. That's just understood to be the square root. And then you have the 3, which would be the cube root. Then we could throw the 4 in and so forth, and this becomes the 4th root, yada, 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 keeps going till all the way to n. Okay? All right. So make sure we got everything. So this guy right here is our radical. This is our radicand. Spell that right. And this is my index. Personally, what I like to do is sometimes when we get into those long, complicated problems, right, is I like to drop this little tail down at the end of my radical, because then that tells me what exactly I'm taking the cube root or the 4th root or whatever I'm taking the root of. Yep. Here, 125. Radicand. How's that? Okay. So, oh yeah, I gotta talk about principles. All right, so we got principal roots. All right, principal roots. So if we just have like this guy right here, there's no signs out in front. This is our indicates the positive principal square root. All right, so then if I do this, I throw the negative out in front. So this indicates, take a wild guess. Yep, opposite or negative. Principal square root. And then we can do plus or minus. Both principal roots. So I gave everybody just a little bit of time to kind of write things down and catch up. So we're on this one right here. So we have the cube root of negative 125 indicates the principal cube root, because again, we're looking out here, okay? We're looking out here. So because it's an odd function, we can actually take and find the cube root of a negative 125. If it's even, you got to do imaginary numbers, okay? So we get to work with those again if you haven't had a chance to work with it. So then we're going to have something like this. So this would indicate or indicates the opposite fourth root, okay? Again, because we're looking at this value right here. All right, so let's work on a couple examples, right? Sweet. All right. Any which way you want to do this problem, you can do it. Let's see here. Let's go plus or minus the square root of 25x to the fourth. Okay. So again, I'm going to kind of use my whole principal idea with the gel. All right. I know 25 gives me 5 times 5. The power here of x tells me that I'm going to write it 4 times. Okay. Plus and minus. The power is 2, so that means I'm going to be circling 2. All right. So I'm going to go plus, give myself a little space. So plus and minus, well, there's the 5. And I have x and x squared. That's not 2x, right? That's going to be x squared. All right? It's not 2x. It's x squared because it's a power. All right? Okay. So we're going to have negative square root of y plus 2, and it's going to be to the 8th power. All right? All right. Now I know my answer is going to be negative, okay? Because I'm looking at the opposite. All right, now y plus 2 8 times. So I'm going to write a pair how many times? How many pairs am I going to write? 4. So I'm going to go y plus 2 to the 4th power. Okay. So far, these have all been what type of roots? Perfect squares. Perfect squares because they're all going evenly out. Okay. All right. So we're going to do the 5th root, 32 x to the 15, y to the 20th. All right. So I'm going to kind of show you a different way of doing this. with the variables. 32, well, that's 2 to which power? Take a wild guess. 32 to what power? 2 to what power gives you 32? 2 times 2 is 4, times 2 more is 8, times 2 is 16, times 2 more is 32. So it's 2 to the 5th power. Okay, so here's the other way you can look at it. If you all have powers, right? What's 5 divided by 5? 5 divided by 5. 1. Okay, so 2 to the 1 power, I'm not going to write the 1 because we understand it to be. What's 15 divided by 5? 3. So that's going to be x cubed. What's 20 divided by 5? 4. So it's going to be y to the 4th power. So if you convert it to powers, you can just take the index and divide each of the powers if it comes out evenly. Okay? Ooh, running out of time. Number 4. All right. At this time, can we do this one? Nope. So this is not possible. Okay? Pause it here. All right, so what we're going to do is we're going to take the 8, break it up into a prime factorization. Again, it's the index is 2, so we're circling 2. 2 dig out, only 1 makes it, and they leave the other guy in prison. So you have 2 times the square root of 2. No, you cannot leave it as a decimal at this time. It has to be in perfect form. Okay, so then let's do square root of 18 real quick. So I know that this is 9 times 2, which is also 3 times 3 times 2. 3 times 3 is 9 times 2. So then again, just like that. And let's do much time? I got 2 minutes. Okay. Well, what's the square root of 25? 5. So I'm just going to do that one out front now. What's 4 divided by 2? So a squared. Now 9 cannot be divided by 2, correct? Okay. So I can change that b to be 8 times b to the 1 power, right? Because when I have the same base and I'm multiplying the exponents, that becomes 8 plus 1, which is 9. So what's 8 divided by 2? 4. What's left inside the radical? B. Okay. All right, so question number 8, the cube root of 54. Well, I know that it's 9 times 6, right? And then 9 is 3 times 3. And then 6 is 3 times 2, right? So the index tells me to circle how many? 3. So this is still inside the radical. I'm going to circle those 3 right there. So 3 times the cube root of 2.